And now it's time to welcome Boris Mejias. Did I say your name right, Boris? Did I get it?
Absolutely. Yeah, perfectly.
Okay.
Very good.
So for those of you who don't know Boris, he's a Postgres solution architect at EDB. I first met Boris at PGConf in Lisbon. I was giving my first Postgres conference talk, and you were in charge of my talk track, and you just made me feel so welcome and comfortable, and it was pretty awesome.
That was a nice talk, I remember as well. I always go to see your talks whenever I can. So.
And then Jelte, you and Boris know each other. You've met before.
Yes, yeah. I also met him at my first conference talk. So that was he did an amazing talk about metal. He was,
yeah, well,
funny. I remember it being very funny. I laughed very hard.
No, it was an
like the gold in my ring, or
as
in heavy metal?
He was making a joke that bare metal was the best because he liked metal music.
Got it.
For deploying Postgres. So no containers, no virtual machines, just bare metal.
So for those of you who are in the audience and don't understand what Postgres storytelling is, you're in for a treat. This is a highly unusual conference talk. It is most certainly not dry. So I recommend that you stay, and let's listen to Boris tell us a story about Postgres. Take it away.
Thank you. And hello, everybody, actually, who is watching this recording afterwards. And thanks for coming to try to see this presentation. It's not a typical technical deep dive with a fast pace that is going to find the answer to a very heavy technical question. This is really, as Claire was saying, storytelling. So it has its own pace. And if you want to stay, it is probably because you are related to the story. It has happened to you maybe before. Or this is a story that could happen to you if you're not careful about taking care of your Postgres database in the best possible way. So this is the most one of the most feared problems in Postgres, which is the wraparound problem. So Iron Maiden has fear of the dark. The Postgres users, we have the wraparound problem. It's kind of a mystery. So I'm going to try to explain what it is in this presentation. So this is Postgres storytelling and support in the darkest hour. And this presentation wouldn't be possible without the help of Scarlett Riggs. She has magical talent for making the illustrations. So all the illustrations come from her. And well, my name is Boris Mejias. I'm originally from Chile, but I live in Belgium since the beginning of the century. And I lived in Brussels before, and I come back regularly to Brussels to meet some friends. And it is in Brussels that I met Monica DBA. So Monica DBA is actually one of the most talented people that I ever met in Postgres. She's not just a support engineer, not just a DBA. She really knows a lot about Postgres, and she should be probably appearing in Postgres Person of the Week, if you know that book. And she works together with Kevin. Kevin is her senior DBA, but actually Kevin is always learning from Monica. They work in a company in Brussels where they do support plenty of other database systems, Oracle, MySQL, and other things. But the Postgres team is the smallest one because it's the newest one in the company. Things are migrating to Postgres. So one of the things that Monica has to do together with Kevin is to enhance whatever has been deployed already by other people, developers, software engineers that were trying to do their best with Postgres. So she brings the expertise to the company. Now, with Kevin, they do have some common practices to kind of like instead of doing a team building, because it's just a short team, they do continuous team building. So every Thursday, they go to the pub and the night. And although this story is going to happen on Friday evening, it starts at the pub on Thursday evening when Kevin was asking the question to Monica, Monica, can you explain me a little bit more about what is this wraparound problem that I heard of? And Monica said, okay, well, let's order a beer first and let me explain you what this is all about. But before explaining you the problem, I need to explain you how does Postgres work with the transactions. So everything in Postgres happens inside a transaction. This is one of the basic stuff for having ACID properties: atomicity, consistency, isolation, and durability. So you have the transaction that start from 0 and goes growing and growing and growing with a number. At a certain point, you're going to have your transaction writing some rows in your table, updating them, deleting them, doing whatever you want to do with it. And that transaction is going to be identified in time with that number. And everything that happened before that number is going to be considered to be in the past, and everything that happens after is going to be in the future. There are, of course, all the kind of things, but in the interest of simplicity, and because we're at the pub, we're going to just ignore all the rest. Just concentrate on this identity of the transaction. And then Kevin says, but this is an integer, right? A number. How far can you go with this number? Is it infinite? No, of course not. It is a big integer, so you are fixed with a size of 4 billion, which is the maximum value that you can get with a big integer. So Kevin said, wait a second, you're not telling me that in a Postgres server, you can only run a maximum of 4 billion transactions. Of course not. What is going to happen is that when you get to that maximum value, the value is just going to wrap around. So is that the problem? No, that's just how it works. You just have a fixed amount of numbers, and you need to get back to your starting point, which I think is number 3 or something based on the implementation. So let's get another beer and let's try to explain what it was going to be really the issue of the wraparound. So what happens is that at this point, our beers are empty, right? So we need to order another beer. And in the same thing that time flows from some time, like a lot of years back in the past, and then it's going to go continuing almost to infinity in the future, as far as we know, we still measure time with a clock. And a clock is also a limited amount of hours. Some people use digital watches, which has 24 hours, or clocks that I like, which have only 12 hours, are enough to measure time and know what is past and present according to our context. So our beers are empty, so let's order another beer. What time it is? It's 9 o'clock. Okay, so let's ask the barman, hey, barman, can we still take orders? And the barman answered, yes, of course, we are taking orders until 11. So it is 9 o'clock, and 11 is a number that is larger than 9, which means that it's in the future. No problem with that. Everybody understands that. Good. They got a beer, they got another beer, and then finally it was time to leave because they didn't serve any more beers. So they went to another pub. They entered the pub and they said, okay, barman, can we still order beers? And then barman said, of course, we take orders until 1. But 1 is a number that is smaller than 11. But everybody knows that it's in the future because the clock is going to wrap around on number 12 and it's going to start back to number 1. But it's so close that the proximity will tell us that this number, it doesn't matter whether it's in the back or not, it is going to be in the future, you know? So that's how it works. All right, said Kevin. So this is nice. So what is actually the problem? And then Monica had to explain something that happened in a party that she was. It's a psychedelic trance music party. She was dancing. It was 3 a.m. She was starting to get thirsty again. And she said, okay, I'm going to order a beer. And she went to the barman. And before she could ask, somebody else was asking like, hey, barman, can I order some beers? And the barman says, of course, we are taking orders until 1. It was 3 o'clock already. And he was taking order until 1. But remember, this was a techno music party, which lasts until 1 p.m. the day after. So that's why it was confusing, because the context, the visibility of your time is larger than what you have expressed as your context for knowing what is in the past and what is in the future. So if it is 3 o'clock and you're taking orders until 1, what does it mean? And this is the wraparound problem, which happens in Postgres when you're not able to understand that your transactions has gone beyond your visibility. I still don't understand how does Postgres fix this, said Kevin. So what happens then when it wraps around? Well, Monica said to Kevin, think about the following situation. What if you were an archaeologist and you find a mammoth, in Spanish, un mamut, a mammoth in the permafrost? Well, I know it's not just as permanent as we thought, because with global warming, this thing is melting. But what if you found a mammoth in the permafrost? And Kevin started to think and said, well, I think I would say like, this mammoth looks like an elephant. Think about time. Think about this in the context of time. You will have to say, this mammoth is from the past because it's frozen. It's completely frozen. So it cannot be that just died recently. It's not in our context of time. It is really way beyond in the past. And this is how Postgres fixes the issue with transactions. When transactions are not in our context of whether it's too close in the past or too close in the future, it just freezes the whole thing. So everything that is outside this is going to be considered frozen. And this is done by the process vacuum. When vacuum is cleaning up dead rows and whatever, it's also going to see whether a transaction is not being used by any, a transaction ID is not being used by any running transaction. And so, okay, well, this one can be put in the past. And this is how it's fixed. Wow, that's clever, said Kevin. I like this. So you just need to make sure that your vacuum process is able to freeze these transactions so that you don't have anything affecting the visibility of the rows. Exactly. That's it. All right. So that was the story for Thursday evening in the pub. Nice conversation. So what happened on Friday is that, well, Kevin goes bowling on Friday evening and Monica just go and have some fun and do some other stuff. And she was preparing some last measurements because of these talks that they have and the pub. She decided to add some monitoring system. And then she put it, and immediately after putting the monitoring system, the alarm started going off and bah, 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 there is some alert. Kevin was worried. So what happened? And said, well, it's just a thing that I set it up to monitor issues with wraparound. We are having some problems with visibility. Okay, says Kevin, I would like to help you, but I see that I'm not going to be just providing anything else that's emotional support, and I really need to go to the bowling. Of course, I know. But before you go, why did you ask me actually yesterday about the wraparound problem? Oh, said Kevin, it was actually David, the software developer, who asked me about that yesterday and whether we were monitoring that or not. David is kind of a pain in the neck and other parts of the body, actually. He always thinks that he's smarter than all the rest, and he always tries to do his own stuff because he knows better, you know? So Monica started to suspect something that David was doing in his own stuff and his own servers, and she needed to probably handle it with care. So Monica said to Kevin, please go enjoy your bowling. I will stay here and I'm going to probably find something and I will let you know. So this is the monitoring that Monica was putting in place. She will go to the PG_database table in the PG catalog, and she will check for all the databases the age of the value of the database frozen XID. This is the oldest visible transaction ID in the entire database. Remember that the instance has multiple databases. So per database, you will identify something that the age is going to be larger than the value of the auto vacuum freeze max age. This is the value that vacuum uses to kind of panic and say like, oh, we have something that is older than what we tolerate. By default, this is about like a 200 million. So the spectrum that Postgres uses is 2 billion, because there are 4 billion, 2 billion values back are the past, 2 billions are the future to the front. So 200 millions is kind of about like 10%. Enough to have like a 90% of time to fix the issue. So at this point, vacuum is going to start like freaking out and trying to freeze as much as possible. But everything that goes beyond that, it means that the vacuum is not cleaning up properly. And that's why the alarm went off, because you need to have some manual intervention at this point. So Monica started to think, okay, I know now that I have this database that went beyond the proper value that's safe. So I need to investigate which are the oldest tables that hasn't been frozen yet. They are old enough to be frozen, but they haven't been frozen yet. She went then to the PG class table, where you can get the table ID, which is the OID, the name of the schema, what is running, the name of the table itself, and then its particular relational frozen XID. This is like the database frozen XID, but this is for the table itself. A relational table is exactly the same in Postgres. She doesn't just search for everything, of course, because there are indexes and stuff like that, but she will search for everything that is a table, a relation, and a materialized view. And then she's going to, again, ask for the age of each of the table and order descendantly so that she will find the first one that she needs to investigate. And of course, she found one. Okay, how do you fix this? There is one way of running, like in panic mode, vacuum freeze, yes? But this one is too aggressive. It's going to be kind of regenerating a lot of walls, and it's going to imagine that this value of auto vacuum maximum freeze age is 0, so everything has to be immediately frozen. Too aggressive, but a normal vacuum should solve the issue, no problem, because vacuum is going to look at those old rows and it's going to freeze them if it is necessary. So she ran vacuum, and she thought that the problem was okay, fine. We'll run vacuum manually to be more aggressive because auto vacuum, for some reason, is not doing the job, and let's check again. The problem was not solved. She did, again, the same ordering, and this table was still at the top, and the age was increasing. So for some reason, vacuum was not able to freeze these values. And this is because probably there was a transaction looking at this table and locking some of the visibility of it, preventing from every freezing action, like in the problem of the techno music party. So what happened? She said, okay, if there is something taking the log of this table, I probably need to check in the PG-Star activity. So she went there, and there are some important values that you can check for every backend inquiry that is running, which is, first of all, the process ID that is running. When did the backend started? This is when the first connection was established, and then you can run multiple transactions in that backend. When the transaction started, which is the XACT transaction start, and then when the query started, yeah, the last query that is running, they are investigating. Then this is you will find it in the stat activity. And then a lot of people are actually worried about long-running queries, but in this case, for visibility, it is actually the transaction that is too long running for too much time. So you need to worry about the moment that the transaction started and measure how much time it's been running. So you do it with now or current timestamp minus the start, and you're going to get for how long a transaction is being running. This is more important than long-running queries, is long-running transaction. Then, of course, you're just interested on the values that are from a client backend and where the transaction start is not null, so you don't get extra information on your table. And you are going to order them by the longest running transaction descendantly. So you will find which transaction is running for the longest. And then she found there was one transaction doing some reporting for 8 hours already. A lot of these were big tables, like 2 terabytes each table. Okay? So Monica said, okay, I found a very long running transaction that probably is affecting the visibility of this table, which is getting too old, and I need to freeze it. How do I make sure, how do I find some evidence that this is really the transaction that is affecting the visibility? Aha, logs. So she went to the table of logs and she searched for, is there anything matching this process ID that I just found on the table ID, which is the relation here in this table, that is actually affecting the visibility. So she just searched for whatever comes in by matching this table in this long-running transaction. And she found something. Okay, so this is the one. It is Friday evening. Everybody's gone. The lights even are out. I will just terminate this backend. The reports can be built during the weekend. I need to fix this issue with the vacuum freeze. This is what she did. She ran vacuum and she went for a coffee. So when she realized that she needed to have some coffee, she stood up. And then these buildings, they have some sensors that after a certain hour, if nobody moves, the lights are out. This is why everything was in the dark. She doesn't mind. I mean, she's not afraid of the dark. This is just the moment that she realized that, oh, wow, this is quite late, but I still want to do some other stuff. So more coffee. She got her coffee. She went back. This is still Davy's system. So probably there is something else there. And then she needed to figure it out. So she continued. She checked again for the databases, which one has a value of the oldest row that is still beyond this limit, this healthy limit of the auto vacuum freeze maximum age. And she found that still this database was having an issue, not with the same aging, yeah, but it was different. So it was improved after vacuuming this table, but it was still there a problem. So she ran again the same query to identify which is the next table giving me an issue. She found it. She said, okay, probably another issue with some long-running transaction, long-running query affecting visibility. But she didn't find anything in the pgstat activity. Okay, so let's try to find any log at all that it kind of got there hanging affecting this particular table. So she didn't have any process ID at the moment to match, but she just wanted to search anything on that table. Nothing, absolutely nothing. So what could prevent AutoVacuum from cleaning up the old table? So this was kind of pissing her off. She didn't understand why, if nobody's touching a particular table, the table is not being healthy enough to freeze all the old transactions. So she meditated. This is a good exercise for everybody. Breathe, concentrate, think about a nice drink, nice music, nice people. And then suddenly might be that you find out what you need to do next. Checking a break is always good. Step back and then come back. She realized, okay, I need to look at the statistics of the table. So she went to the pgstat user tables and she looked at the following information. How many tuples were inserted in this table? How many tuples were updated and deleted? Then how many live tuples are in the table? And how many dead tuples, or tuples? That is going to trigger the AutoVacuum, because when you have too many dead rows, you're going to have to clean it up, vacuum them, okay? So she also wanted to see whether there was something wrong. Maybe somebody disabled AutoVacuum on this table. So she checked for the last time that vacuum was run, last time that AutoVacuum was run, and how many counts were there. The table was the payment logs, okay? A very large one. And then she realized that the amount of inserted rows was the same as the amount of live tuples. That means that this was just an insert-only table. So 7 billion rows was like 4 terabytes of data in this table. So it was a very, very large table, but without any dead rows. So that means that vacuum was never really triggered. But still, AutoVacuum was running multiple times. And the last time this was Friday evening in February. And the last time was really recently. So AutoVacuum was really trying to clean up this table, although there are no dead rows, but it was trying to freeze the old transactions. But it was not just able to do that AutoVacuum. Then she realized, which version of Postgres is this one? And then she checked for the version, is version 13. She said, there's still an issue with this one. So what happens is that when you have an insert-only table, the vacuum is only going to run when it surpasses this value of the AutoVacuum freeze maximum age, and it starts to panic and say like, oh no, I need to do this because we haven't vacuumed this table all along. In newer versions of Postgres, 14 or 15, this is why you have to upgrade. Postgres will do it after a certain amount of inserted rows, even though there's no dead rows, it will still do the vacuum just to freeze all transactions. So the problem is that when it triggers this value, it's already kind of late, and multiple rows, multiple tables are going to have the same issue if they're all of them inserted only. So what is happening is that AutoVacuum is trying to clean up as fast as it can, but the table is still growing much older. This is like trying to vacuum in a party. Imagine that you are in a party and then trying to clean up, and the party is making more mess faster than we are able to actually clean up the room. So this is what is going on. So she said, okay, probably if this system was set up by David and we haven't been able to touch this system before, the AutoVacuum is not being tuned yet. Aha. So this is what Monica figured out. I have found the issue that this table is not being vacuumed enough or not fast enough. So I need to check the following parameters. AutoVacuum cost delay, which is by default 20 milliseconds and needs to be much shorter. So she reduced it to 2 milliseconds, which is one of the new default values. And the AutoVacuum vacuum cost limit was actually set to -1. Usually -1 will mean infinity. But in this case, it just means that it's not being set up and it's going to be used the default one of vacuum cost limit, which is about 200 units of work. Not enough. So she increased that one to 4,000. The idea is that your auto vacuum will be able to run much faster, do a lot more work, and then continuously advancing and making progress. So it's like instead of vacuuming in a party with a small vacuum cleaner, you will be able to vacuum with a larger one and do a lot more time doing in between. There's no reason to say like, oh, stop the party, everybody goes out, I need to clean up, and then you can go back and continue the party. Not necessary. Auto vacuum will do it for you. So never disable auto vacuum and try to tune it properly. So this is what she did. And she said, well, I'm not going to even run vacuum freezer or vacuum manually. I will just let auto vacuum fix the problem for me, because that's his job, you know? So this is what she figured out. She make sure that no other parameters were set specific for that particular table, so the global values will be enough. And she went for another coffee. Again, lights went on so that she could safely walk to the kitchen, then get another coffee. Because she was still not happy about the entire thing. There was still something else that she needed to investigate, because this is David's system. So auto vacuum started to run, multiple process, and the age, it was not fixed immediately, but it was decreasing. It's like Dorian Gray. The table was getting younger and younger and younger because the oldest rows were being frozen. Very good. Auto vacuum fixed the problem on its own. But Monica wanted to continue investigating before ending the day. So she wanted to see the login of the queries, and she figured out that every minute, so this was probably a cron job, there was this query trying to figure out the age of the databases. The query was run from a remote machine, so probably Dave's machine, trying to monitor this thing. And it was saying, give me the database, give me the current transaction ID, and then get the distance from the current transaction ID and the oldest transaction ID in this database to calculate the age. A reasonable thing to do, I would say. But the thing is, Postgres will never increase the transaction ID unless you're writing something. It's only useful when you insert, update, delete, or do something like a DDL. If you're just reading, it will never create a transaction ID for that particular one. There are some other stuff that are extra, but in the interest of simplicity, I will just leave it like that. Of course, it will generate a new transaction ID if you explicitly ask for it. And this is what David was doing. He was asking for a new transaction ID for the current transaction, although it was not necessary because this was just a reading transaction. So it was consuming transactions ID every minute. Not that it was going to be a real problem. I mean, there are not as many minutes in a day to affect really the problem, but it's bad practice. The best is to just use what Postgres is giving you to calculate the age of a database, which is this function age with whatever XID you provide. It can be from the database, it can be from the table, it can be from a row. You will know the age by using this function. So she did three things after this. She sent a message to Kevin, not to worry about, so that everything was fixed. She sent a message to Jean-François, the boss, asking for upgrading all the system from Postgres 13 to at least 14 or 15. And she sent a message to David to please stop running select TXID current just for the sake of it. Okay, so Monica was happy. It was time to go for another coffee, she thought, but no, it's already too late for a coffee. She went for another beer at the pub. And this is where I met Monica, actually. And she started to tell me about the whole adventure about Friday evening and Thursday evening. And this is how I got to know about this story. And that's why I can tell you about it now, right now, thanks to this nice encounter between people. That's all for me. So thank you for listening. And I hope that you enjoy the story and maybe you learn something about wraparound problem. Thank you very much.
Hey, so I guess we have two people to thank for that amazing talk. You, obviously, for putting it together, conceptualizing it, delivering it, but also big shout out to Scarlett Riggs. Wow.
Yes. She is really good.
The artwork is just beguiling. It really is.
Thank you. I will pass the message, absolutely.
Yeah, it looks amazing.
So one of the things I wanted to say, in addition to seeing you present today, I wanted to let everybody know, and I'm going to pop this up here really quickly, that you are also going to be a guest on Path to CitusCon on May 3rd. So that's coming up in a couple of weeks. You and Alvaro Herrera are going to be joining us to talk about why giving talks at Postgres conferences matters. And because you've obviously been doing this for decades, as has Alvaro. He's a Postgres committer and does his own brand of trainings and stuff. So anyway, I wanted everyone to know there's a URL on the top right of the screen where they can grab the calendar invite if anybody wants to join on Discord and listen in.
Thanks for that invitation, Claire.
Yeah, I don't know what you're going to say, but we'll find out when we get there. So Hjalte, do we have questions for Boris? I know we have to move quickly to the next speaker.
With one question. You've done some support as well, right? How often do you see this wrapper problem? Is it super common, or is it sort of a rare one?
It is becoming a little bit. It is becoming more common recently because of the amount of data that people is putting on the databases and the amount of workload that is being. I mean, we saw it in the previous presentation about the amount of transactions per minute that you can add and all this kind of stuff. So yes, it is becoming a little bit more common. And there are two things that Postgres is trying to do. Either is to change the way that this 4 billion transactions is the limit, to have a larger spectrum. And the other things are a little bit more ambitious to have different type of storage system like the C-heap and things like that. But until we get a proper solution for that, I think it's very important to just make sure that your auto vacuum is working properly. If your vacuum system is working nicely, you never have this problem. That's the main thing. Observe the visibility, observe for long-running transactions, and then you should be fine. I mean, if you're careful, this is not going to be hitting you anytime.
Yeah. Okay.
And then I just have to ask one more question. I know you have a PhD in computer science. I'm just curious, have you been working with Postgres since your grad school days, or is that something that happened later in life?
So I did some Postgres before I did the PhD with Alvaro, actually, in 2001. That was my first work with Postgres. But then I went to do the academia part, and I worked with actually peer-to-peer systems, so things very similar to Citus and MongoDB. But when I needed to compare some of the algorithms, I came back to Postgres to see how Postgres implemented two-phase commit, for instance. And then I was easy, although I don't program that much in C, but it was super easy to learn from the code itself. And then I said, wow, this project is super cool. I need to get back to do some Postgres stuff. This was, I think, 2008 or something like that. So, and then what I do is kind of mixing whatever I learned during my research in the PhD with whatever I do with Postgres now. So I try to do the merge and have a holistic view of the whole thing.
Bring those things together. Well, thank you very much. We'll see you on Path to CitusCon on May 3rd, Wednesday at 10 a.m. And you're going to go to the Discord, I'm sure, to answer questions and talk
Absolutely.
To the
I'm going to stay
there.
hanging out in this Discord, not just today, but the rest of the week as well.
Okay. Awesome. Thank you, Boris. Thank you so much.